Polynomials. In this module, you will learn about polynomials and the geometrical meaning of the zeros of the polynomial. Have you ever enjoyed a roller coaster ride? Do you know that polynomials are used to define the curves of various paths on which they move? The designing of a roller coaster is the application of polynomials. Have you ever noticed the path formed by a ball? When a tennis player makes a beautiful shot, like this, the ball's path is a parabola. Polynomials enable people to describe the physical world. Do you know what this is showing? This is a stock exchange variation graph. The stock exchange uses polynomials to compare various data points on the curve to find the deflection of prices. So, you can see polynomials are important in our daily life. We define polynomials as an algebraic expression in which one variable that consists of the terms of the form ax(n), where n is a non-negative integer and a is a real number called the coefficient of the term that can be joined by addition, subtraction, and multiplication. For example, the expression 5x square plus 3x minus 7 is a polynomial in variable x. Let us see the classification of polynomials. Polynomials are classified on the basis of degree and on the basis of terms. The highest power of x in Px is called the degree of the polynomial. A polynomial of degree 1 is called a linear polynomial. A polynomial of degree 2 is called a quadratic polynomial. A polynomial of degree 3 is called a cubic polynomial, and so on. A polynomial having only one term is called a monomial. A polynomial having two terms is called a binomial. A polynomial having three terms is called a trinomial, and so on. We have already learned about the zeros of polynomial Px. The zeros of a polynomial are simply those values of the variables where the polynomial as a whole equals 0. For example, x square minus 14x plus 49 is a polynomial. If we put x is equal to 7, then we get a 0 value. This means x equal to 7 is the zero of this polynomial. Let's see the geometrical representations of linear and quadratic polynomials and the geometric meaning of their zeros. We can find the zeros of a polynomial by just observing the graph of the polynomial. First, we see the geometrical representation of the zeros of a linear polynomial. For this, we consider a linear polynomial Px is equal to 2x minus 2. We can write it as Px is equal to y is equal to 2x minus 2. We tabulate the values of y corresponding to the different values of x. When we put x equal to 0, we get y equal to minus 2. When we put x equal to 1, we get y equal to 0. When we put x equal to minus 1, we get y equal to minus 4. When we put x is equal to 2, we get y equal to 2. Now, we plot the graph of the given values. We already know that the graph of a linear polynomial will always form a straight line. We see that the graph of y is equal to 2x minus 2 intersects the x-axis exactly at 1, 0. We also know that 0 of 2x minus 2 is 1. So, we say that the 0 of the polynomial 2x minus 2 is the x-coordinate of the point where the graph y is equal to 2x minus 2 intersects the x-axis. In general, for a linear polynomial Px, where Px is equal to ax plus b, a is not equal to 0. The 0 of the polynomial occurs only for one point, that is, minus b upon a, 0. Secondly, we observe the geometrical representation of zeros of a quadratic polynomial. For this, we consider a quadratic polynomial Px is equal to x square plus 2x minus 3, we can write it as px is equal to y is equal to x square plus 2x minus 3. We tabulate the values of y corresponding to the different values of x. When we put x is equal to 0, we get y equal to minus 3. When we put x is equal to 1, we get y equal to 0. When we put x is equal to minus 1, we get y equal to minus 4. When we put x is equal to 2, we get y equal to 5. When we put x is equal to minus 2, we get y equal to minus 3. When we put x is equal to minus 3, we get y equal to 0. When we put x is equal to minus 4, we get y equal to 5. Now, we plot a graph of the given values. We will see that it looks like a parabola. So, we say that the quadratic polynomial forms parabola. We see that the graph of y is equal to x square plus 2x minus 3 intersects the x-axis exactly at 1, 0 and minus 3, 0. We also know that the zeros of y is equal to x square plus 2x minus 3 are minus 3 and 1. So, we say that the zero of the polynomial x square plus 2x minus 3 is the x-coordinate of the point where the graph intersects the x-axis. Here, we can also observe that the coefficient of x square is positive, so the parabola drawn is open upward. Now, see what happens if the coefficient of x square is negative. For this, we take another polynomial qx, which is the negative of quadratic polynomial px. Now, qx is equal to minus x square minus 2x plus 3, and we also write it as qx is equal to y is equal to minus x square minus 2x plus 3. There are some values of x and y satisfying the polynomial. When we plot these points, we observe that it is just the reverse of the parabola drawn. It is open downward. It means that changing the sign of a polynomial inverts its shape. When we draw the graph of the quadratic polynomial, then three cases arise. Case 1. The graph cuts x-axis at two distinct points A and B. The coordinates of A and B are the two zeros of the quadratic polynomial ax square plus bx plus c is equal to 0. Case 2. The graph cuts x-axis at one point. The coordinate of A is the 0 of the quadratic polynomial ax square plus bx plus c is equal to 0. Case 3. The graph is either completely above the x-axis or completely below the x-axis. So, it does not cut the x-axis at any point. So, the quadratic polynomial ax square plus bx plus c is equal to 0 has no 0. So, we see geometrically that a quadratic polynomial can have either two distinct zeros or two equal zeros or no 0. This means that a quadratic polynomial can have a maximum of two zeros. Geometrical representation of the zeros of a cubic polynomial. Now, we look at the cubic polynomial px is equal to x cubed minus x. Here, minus 1, 0 and 1 are the zeros of the polynomial. We draw a graph of this cubic polynomial by tabulating a few values of y corresponding to a few values of x. Now, we plot a graph of the given values. Hence, There are maximum 3 zeros for the cubic polynomial, that is, any polynomial of degree 3 can have maximum 3 zeros. In general, any polynomial of degree n can have n zeros. Let's recap. An algebraic expression of the form anxn plus an minus 1xn minus 1 plus a2x square plus a1x plus a0, where an minus 1, and so on up to a2, a1, a0 are the real numbers, and n is a non-negative integer is called the polynomials. For a linear polynomial px is equal to ax plus b, a is not equal to 0, option a not equal to 0, the 0 of the polynomial occurs only for one point, that is, minus b upon a, 0. For a linear polynomial can have maximum 1, 0. The graph of the quadratic polynomials cuts the x-axis either at two different points or two coinciding points, or do not cut anywhere. A quadratic polynomial can have maximum 2 zeros. The graph of the cubic polynomial cuts the x-axis at 3 points. A cubic polynomial can have maximum 3 zeros.